nagpasa ng COR, ano naman na verified naman na lahat. So, wala na tayong problema sa class list. And what else? Yung groupings, I can see you guys are filling up very good. And yeah, actually very good kasi ang dami pa ding pumasok. So, almost perfect attendance pa rin tayo. Yeah. Yeah, the reason why I got your groupings na, yung sa mga hindi pa nakakapaglagay if meron, lagay lang kayo dun. But I don't think meron pa. Ilan groups na ba to? 1, 2, 3, 4, 5. So, 5 people per group. So, kulang pa to ng dalawa or isang grupo siguro. Kulang pa. So, kaya kinuha ko na 'to kasi magbibigay na ako ng, lecture activities and lab activities din. Right after the discussion, I will post the module na. Then, I'll inform you na lang kasi fina-finalize ko pa kung kailan yung magiging deadline. Pero hopefully next week kasi asynchronous naman buong next week, 'di ba? Since nakita niyo yung schedule. So, async tayo next week. So, I will be giving you the time para i-accomplish yung lab and lecture activities ninyo since medyo marami-rami siya. But regardless, ano naman, almost the same lang yung idea na i-apply nyo for the first module ng lecture, yung activity dun, and dun sa laboratory. So, purely concepts pa lang din siya. So, let's hurry up na para makapag-move forward na tayo dun sa propeller construction natin kasi medyo mahaba-haba yung activity na gagawin doon. What else before we proceed? Okay, kinokolekta ko pa rin yung mga SolidWorks license. And at the same time, pina-finalize ko pa rin kasi yung sa lab activities nyo, I think gagamit kayo ng AutoCAD talaga one way or another. Since, yeah, meron siyang, it involves processes of projections and interpolations. So, mas accurate siya, I think, kapag sa CAD. Yeah. So, what we are going to do today is I'm going to present a pre-recorded video. And I'm gonna pause it as we go through it. Kung meron akong i-add, kasi I think meron pa akong mga add-ons dito. And syempre, if alam niyo yung may mga part kasi dito na may questions. So, if alam niyo yung sagot, you can answer. Okay, meron ba munang concerns regarding dun sa groupings or sa schedule? Wala I don't think may magko-conflict naman kasi kumpleto naman kayo lagi. So, ayun. Yeah, Mr. Ragudo, you raised your hand.
Ma'am, kailangan na po ba ngayon ng AutoCAD discussion today?
Hindi pa naman. Hindi pa naman. Lesson 1 pa lang naman. So,
Thank you po.
why? May issues ba sa license ng AutoCAD? Or
Mag-i-install lang po ulit ako kasi wala na po yung AutoCAD sa laptop.
okay, okay. So, just ano na lang din, make sure na lang din na each group meron. Ano ko naman kayo, inform ko kayo ahead of time kung yun yung gagamitin for that activity or kung gagamitin man natin kung saang part, okay? So, meron pa bang questions, concerns so far? Okay, so I'm guessing wala na. So I will be playing the pre-recorded video and just message kayo kapag if ever may problema din sa audio or sa mismo. dun sa pinaka PowerPoint kung hindi visible. Okay? So, wait lang. Let me share my screen. Okay. Kita ba ng lahat? Nakikita nyo guys? Okay. So, I will be playing it now. Hi everyone, this is the recorded version of the first lesson that we would be having for... Guys, rinig ba yung audio nung video? Malinaw naman?
Dinig po.
Okay, thank you. Our propeller and helicopter. Okay, so as I've told you sa ating orientation, all of the topics that we are gonna cover for the prelim is under ng propeller. So this presentation, it is an introduction and classifications of aircraft propellers. So these are the following topics that we would be discussing. First, we would just have a brief introduction. Then we move on to propeller nomenclature, and then propeller theory, propeller classifications according to position, propeller classifications according to establishing pitch, propeller construction, and if I have assessments or announcements. Which regardless naman, for the seventh part, most likely, upo-post na lang ako sa Google Classroom. Now, for our introduction, we should start with the question. What are propellers? Okay, so does anybody have an idea what are propellers? Just kahit rough words lang in your own words. Okay, Ragudo.
Propellers are used to, as in the word po, to propel the aircraft either upward or forward through the air po.
Okay, so yeah, it's basically an aerodynamic device used for uh, production of thrust. So yeah, to further explain, I'll play the video again. So to put it simply, an aircraft propeller is what? It is an aerodynamic device which is used for what? Providing force or thrust. Same sila ng pagkakashape ng wings in a sense na pareho silang airfoil. But instead of producing lift in a vertical direction, propellers produce lift in a forward direction. And this is what we call the thrust. And just additional info, baka lang kasi mag-consult kayo ng ibang references. Ang gamit nila for references that originated from Great Britain, Germany, or France, they don't normally use the term propeller, they use the term air screw. So if ever, wag na lang kayo magugulat if you encounter that term. So air screw is basically just another term for propeller. Okay? So, how do propellers produce thrust? So pretty much it is by converting the rotational energy into propulsive force, therefore creating thrust, which is approximately perpendicular to its plane of rotation. We will be discussing it pa further sa mga susunod na lessons. Pero I chose to start with these two questions para kumbaga ba ma-boost up lang yung ating interest. So here we have a brief history rather. which also contains the improvements and innovations. Just like any other part of an aircraft, propellers are subjected to lots of improvements as well as innovations, which are evident sa history niya. So, what is the most widely used material for our propellers? So, meron tayong mga kaya-consider. Syempre, if we are to consider the structural strength and let's say we need a thinner profile, syempre, aluminum alloys. Pero, meron pa din naman na nag-exist na gawa sa wood. Later on, at I think it's the last topic, if I'm not mistaken. Yeah. So, for the propeller construction kasi, we would be discussing yung mga materials. But regardless, let us move on sa ating second topic, which is the propeller nomenclature. So we have two pictures right here. So I think you've encountered this term before, but what is nomenclature? Okay, does anybody have an idea? Na-encounter nyo na to before kung hindi sa aerodive baka sa GTE. May idea ba? Anybody? Okay. So basically, nomenclature is the system of naming things. And sa case natin, it is the system of naming the parts that makes up the propeller. So bakit natin kailangan pag-aralan yung propeller nomenclature? Going back dun sa idea ng function ng propeller, which is to produce thrust, we need to study this to be able to fully understand how the process works, since this is a vital component nga. We have here on the first picture yung parts, the hub assembly. The hub pretty much allows the mounting of the propeller to the engine crankshaft or at other cases reduction gear assembly. So yeah, as you may see doon sa ating hub assembly, meron siyang butas na malaki sa gitna. It is called bore, hub bore. Pretty much, siya yung butas sa gitna. And yung mga mas maliliit is what we call the bolt holes. Bakit merong mga butas dyan? Kasi nga, yung hub assembly natin is the key to attaching it to the crankshaft. So, it makes the process of mounting possible. So, going dun sa shank or also called as root, yung pinakamalapit na part sa hub, yun siya. This is designed to primarily strengthen the blade, syempre. And yung tip, yung pinakamalayo na part sa hub, as pointed there. So yung second picture naman indicates the usual materials used for respective parts. So that's pretty much it. Okay, we have here two more photos. So since ang shape nga natin is airfoil, as I've said before, we have then the terms like trailing and leading edge, the chord line, and of course the bleed angle. The blade angle, take note, is the acute angle formed by the propeller's plane of rotation to the chord line. Take note na ang plane of rotation ng ating propeller is always perpendicular to the engine crankshaft. For ano naman, this is for ano lang kasi as you may see sa example natin sa picture, usually fixed pitch talaga yung ginagamit na example. Pero in any case that we have na adjustable. Okay, so sa design nyo, nabigay naman na yung, like pinagawa na kayo nung initial na specifications nyo, right? Fixed pitch naman yung propeller requirement nyo. Confirm ko lang, diba?
Opo, ma'am.
Okay. So, yun. Kaya din yung reason kung bakit inisa din namin yung group nyo for design and propeller kasi for our lab activity 2, kailangan natin yung um, hindi naman lahat ng initial specs nyo, pero some of it, especially yung process kasi niya is magko-conceptualize kayo ng propeller para dun sa design nyo sa 416. Okay, so tuloy natin. So again, fixed pitch lang yung gagamitin natin. Blade angles. They use removable blades that are secured sa ating hub assembly by a set of what we call the clamping rings. Ang unique terms lang naman dito sa elements na ito when we compare it to the wing airfoil is yung blade back and blade face. So always take note na baka malito lang kayo since medyo um, identical siya, blade back and blade face. So always take note na blade back is yung cambered side and blade face is yung ating flat na side. So yung sa plane of rotation and axis of rotation, I would be showing, mas maganda kasi siyang ipakita in 3D. So later on, mas maintindihan natin siya. So we have here cuffs. So what is blade cuff nga ba? Pretty much a blade cuff, it is an airfoil shaped attachment then. It can either be made of thin sheets of metal, plastic, or even composite materials. So bakit nga natin kailangan itong blade cuffs? Ano bang function nito? Bakit ito nandito? Blade cuffs increases, what do you call this? The flow of cooling air into the engine. So, for the purposes of cooling, unlike the fixed pitch, so meron tayong space dyan for cooling. Ano yung ginagamit natin na pang-connect sa cuff and sa blades? As you may see there, di ba? Connected sila. So, these are mechanical clamping devices and adhesive bonding agents. So, gumagamit tayo nun para ma-attach yung ating blades sa ating cuffs. The next one is, eto, nandito na tayo. So, to aid in identifying specific points along the length of our propeller blade, most blades have several defined blade stations. So, ano nga ba ang blade station? I think you encountered this term na sa inyong gas turbine engine. But regardless. Okay, does anybody have an idea kung ano ang blade station, para saan siya ginagamit? Okay, so, pero na-encounter nyo na to before? Or, Eskandor? Yes, you're raising your hand.
um, ginagamit po yung stations para po ma-identify yung different cross-sections ng isang blade o propeller po, I mean.
Okay. So, very good na. Isa yun sa reasons. Siyempre, yung sa cross-section. Since later on, madidiscuss din nga natin yung pitching. May iba-ibang subjected yan sa iba-ibang angles. Hindi siya same ng angle throughout the propeller. So, anong tendency nun? If we look into the cross-sections of the stations individually, iba-iba siya. As you can see din dun sa presentation, right? And kapag nagna-number ba tayo ng blade stations, mula saan siya mini-measure? So, blade stations are measured from where? Baldrias.
I think it is
Okay, yes,
measured po
Baldrias.
from the center of the hub po.
Okay, very good. So, always remember na kapag mag-measure tayo ng stations, laging yung pinaka-reference point natin is center ng ating hub. Okay, so doon nagsa-start station 1, station 2, all the way as we reach the tip. Okay, so let's proceed. A blade station is a reference position on a propeller blade that is measured from, take note ha, it is measured from the center of the hub. So this is important lalo na kapag magde-design na kayo ng propeller. As you may see, nagva-vary yung shape ng airfoil together with the bleed angle as we go through the route to the tip. As you may observe there. Bakit? Why? So, okay, does anybody have an idea? Bakit, diba, na-mention ko kanina, iba-iba nga yung angle. So, technically, iba-iba din yung cross-section. So, bakit? Bakit iba-iba yung angle natin in the first place? Okay, I see a hand. Manuel?
Kasi magkakaiba po yung speed nung part ng propeller depende po sa radius dung sa length niya po from the center.
Okay, very good. So, technically, hindi kasi pare-pareho ng distance na tinatravel yung ano natin, yung sections natin, stations natin. So, the more na malalayo siya sa hub and sa more na malapit na siya sa tip, doon na sa dulo. So, mas malayo yung tinatravel niya na distance at the same time kesa dun sa malapit sa ating hub. So, to compensate for that, we do pitch distribution, also known as pitching. This is to compensate for differences in rotational speed and provides a relatively even distribution of thrust along the blade. Kasi nga, in the first place, hindi naman same ng distance lahat ng stations from the hub. So, each station, magkaiba ng speed na tinatravel. Yung gradual decrease ng ating blade angle, starting from the hub, going to the tip, is called pitch distribution, also known as twist. So, take note of that. Pitch distribution, also known as twist. So, since na-discuss na din natin na hindi pala pare-pareho yung yung distance na travel nila and yung speed nila. So, which part do you think travels faster? Is it the tip? Is it the root? Or is it the middle part? Okay, so I believe nasabi ko naman na kanina na mas mabilis yung nasa tip kasi nga mas malaki yung nako-cover niya at the same amount of time ng pag-ikot. So the answer for that is the tip. The tip of the blade travels faster than the part nearer to the hub because it travels a greater distance than the hub itself in the same length of time. So, given this situation, the tip, yung tip natin, it requires thin profiles lang, na airfoil profiles pa din, to minimize our drag. So, what would happen kung constant yung bleed angle natin throughout propeller kung hindi tayo magto-twist? Since meron ngang variation sa speed due to the distance, thrust and pressure would vary greatly from the root to the tip if the blade angle was constant throughout the propeller. So at the root, there can be a negative angle of attack and the tip of the blade might stall. So pretty much, ayun lang. Kaya tayo nagtutwist kasi syempre, iba-iba nga sila ng distance. So, ang tendency kasi niyan, since mas mabilis yung nasa tip, magiging mas subjected siya ng damage. Therefore, stall din. So, when it comes naman sa section na nagpo-produce ng most of the thrust, the middle section generates most of the thrust. Take note of that. Bakit? Since, this section kasi yung shape niya and twists are designed to be aerodynamically efficient. And at the same time, masasatisfy pa din niya yung requirements ng blade when it comes to strength and stiffness. So, siya yung section na nag-generate ng most thrust. So, medyo critical yung ating dapat shape requirements for this one. Kailangan aerodynamically efficient pa din siya and strong and stiff. So, kung nagtataka kayo bakit pinakamakapal yung sa root section, ang primary reason dun is for structural stability. Kasi yun yung, kahit i-simulate pa natin, yun yung part na na-expose sa most stress. So, a blade's root should be the thickest part. Okay, so now we move on to propeller theory. So we have here an example for fixed wing since okay, familiar naman ba yung not the specific photo pero familiar sa idea ng lift generation, right? You must be. Familiar naman lahat? Okay. I believe mas magigets natin siya kapag yung transition is magmumula sa fixed wing since we are well versed na with the lift and drag production. We can highly relate this sa ating rotary wings. So how does propeller produce drag? Since we know na same na airfoil sections ang ginagamit for both propellers and wing, can we apply the same ideas as to how a wing generates lift as to how propellers generate thrust? So, does anybody have an idea? Can we apply the same theory sa fixed wing and sa rotary wing when we, well, not exactly sa rotary wings, pero sa propeller natin? Can we apply the same idea ng lift generation, yung low pressure, high pressure? Anybody? Okay, so baka na ano pa. Okay. Guys, na-absorb ba yung mga previous na na-discuss na? Ma'am, nawawala po ata. Okay, nawawala ba yung connection? Naririnig pa ba?
Naririnig po.
Okay, so questions, clarifications, may hindi ba naiintindihan? So far? Okay. So, I'm guessing wala naman. Ano, guys? Guys, naririnig niyo pa ba ako?
Yes po.
Okay, so, carry pa naman, na-absorb pa. Okay, so parang hindi sure. Okay, so anyways, ano naman 'to, bibigyan ko naman kayo ng copy nung, recorded copy. And by the way, hindi ko lang siya binis dun sa modules. So, nag-consult ako ng ibang references to make this, pre-recorded video. So, mas maganda yung mas madami tayong references na napagko-compare. Okay? So, let's, wala bang questions? Okay, wala naman. So, yeah, proceed na natin. So, let's take a closer look. To answer that question, same principle lang siya. Meron tayong low pressure on top and high pressure underneath. That difference in pressure, it will give us what? Lift, which counteracts what force? Of course, the weight. And we have then our drag, of course, in exchange for the lift. Now, with the propeller naman, we still have that airfoil shape pa din, giving us the same theory sa propeller natin. But this time, we don't call it lift and drag. We call it thrust and torque, as you may see in the picture. I put it there side by side para mas madaling makita yung resemblance, para hindi tayo malito. Since iba nga yung terms na ating gagamitin. And normally, thrust and torque is shown as the third photo. And as you can see, when we're talking about propellers kasi, it's not called angle of incidence anymore. It is called propeller blade angle. Again, propeller blade angle, it is the angle between the chord line and the plane of rotation. So, mas na-imagine na natin yung plane of rotation dito sa figure na to. Pero we have a more prominent figure later on. So, the amount of thrust produced depends on several factors, which includes first the propeller blade's angle of attack, the speed, and the airfoil shape. So now that we know the behind the production of thrust line. So the direction. Okay, so na-define na both yung angle of attack and yung ating propeller blade angle. So can anybody tell me kung ano yung pinaka difference nila rather? Anyone? Blade angle, difference niya sa propeller angle of attack. Okay, Sancho.
Ma'am, yung blade angle po is yung angle po ng propeller po relative po sa yung rotational plane of rotation. Tapos yung angle of attack po is yung angle po galing po sa chord line relative po sa wind po. Relative wind po. Yes.
Okay, so very good, Sancho. That's exactly their difference. Baka lang kasi malilito kayo kasi merong time na magiging same sila. Again, repeat ko lang ha, sa angle of attack, siya yung angle na na-form from the chord relative to the relative wind. And the blade angle is measured from the chord relative to the plane of rotation. Okay? So, yeah, later on, ma-discuss natin kailan sila magiging pareho and ano yung magiging effect sa kanila nitong magiging changes natin sa speed. So, meron kasi tayong rotational and forward speed. So, guys, wag kayong malilito dun rotational and forward speed. Yung next figure na i-show ko para more on ano siya, 3D approach niya para hindi niyo mapag-interchange yung rotational speed yung vector ng rotational speed sa ating airspeed. Okay, so proceed tayo. Direction of the relative wind is determined by what? The speed of the aircraft. This speed moves it is determined by the speed of that aircraft moves through and the air and the rotational motion of the propeller. So, para maintindihan natin lalo yung sinabi ko, here is a picture. Diba? I told you, mas maintindihan siya when it is represented in this view. Medyo naka-3D siya. So, as you can see there, yung ating plane of rotation, naka-annotate siya dyan, yung axis of rotation, and meron tayong mga vectors. In this image, as the propeller rotates, let's say at a clockwise rotation at the plane. Again, for the rotation, it is always stated naman, pero again, if magko-consult kayo ng ibang reference, it's not always clockwise. Okay? It's not always clockwise. So, before you compare, make sure to take note kung paanong rotation. Okay? Kung clockwise or counterclockwise. Pero sa reference na pinagbasihan ko so far, clockwise pa lang naman. Okay? Of rotation. This rotational speed will have a vector. So you can see it there na vector due to rotational speed. And as the aircraft naman move forward, this will also have a vector. Kapag naka-indicate sila, they will have, syempre, a resultant force. And yun yung tinatawag nating relative airflow. So dito napapasok yung minention natin kanina na relative wind. So, again, angle of attack is the angle formed by the chord line of the blade and the relative wind. And ang difference naman niya sa blade angle is that blade angle is the angle between the chord line and the plane of rotation. Take note of that. Now, kailan sila magiging pareho? Magiging pareho sila when we have no forward velocity or stationary yung ating aircraft. Bakit? Kasi going back dun sa vectors na pinakita ko kanina, wala tayong magiging vector for velocity kasi nga, stationary siya. So, yung direction ng relative wind will be exactly opposite to the rotational movement of the propeller. So, as you may see there, kapag walang forward velocity, same lang sila. And, ma'am, what will happen naman if we have a forward velocity na? Simple, as shown dyan sa ating picture, nag-shift yung ating relative wind kasi nga, may vector na tayo sa baba. So this time, hindi na equal yung dalawang angles natin. In other words, to simply put it, increasing the speed will cause a decrease sa ating angle of attack. So, nagets naman ba yung idea dun sa picture? Kasi, di ba, we represented it as vectors na sa triangle. Diba? So, kung nagiging same siya kapag wala tayong forward velocity, kasi exactly yung axis of rotation, same siya sa direction ng ating relative wind. So, nagtatapat siya. So, kapag naman meron na tayong forward velocity, ayan, mag-move siya kasi magkakaroon na siya ng leg dun sa baba. Diba? Always see it as a triangle, guys. Life hack siya, actually. If hindi ma-memorize ng ayos yung relationships na kapag in-increase ko to, magde-decrease ba, mag-i-increase ba yung angle of attack? Ganun. To put it simply, just take note dun sa triangle na given kanina kasi mas madali siyang matandaan. Habaan nyo lang yung leg as a representation na tinataasan nyo yung magnitude ng certain vector niya. Okay? So, ayun lang naman. Take note of that. So, what happens naman if there is an increase naman in the propeller's rotational speed? Take note ha, rotational speed. Going back sa ating vector, we will have a longer vertical component, meaning we will have a bigger angle of attack as shown in the picture. So, take note ha, rotational speed to. So, what happens naman if there is an increase in the propeller's rotational speed, pero maintain lang yung ating forward velocity? We will have an increase in angle of attack kasi basically, the propeller's trailing edge moves a greater distance for the same amount of forward movement. So, this raises the angle of attack by increasing the angle at which the relative wind strikes the propeller blade. Okay, kindly take note of these info. So, what is the most effective angle of attack for a propeller blade. So the most effective angle of attack for a propeller blade is between 2 and 4 degrees. Any angle of attack exceeding 15 degrees is ineffective because a propeller blade might stall. So take note of that. So we hear na sa propeller theory, unlike a wing which moves through the air at a uniform rate, the propeller sections near the tip rotate at a greater velocity than those near the hub. So the difference in rotational velocity along a propeller blade segment can be found by first calculating the circumference of the arc traveled by a point on that segment. Again, going back sa fact na the tip does not travel the same speed as the root, we have differences in rotational velocity kapag propeller yung pinag-uusapan. We will get the rotational velocity by multiplying the circumference, which is of course 2 pi r, sa ating engine speed, which is in RPM. Make sure to always convert it to miles per hour since velocity ang hanap natin. And kapag nakuha na natin, we can say na at a certain station, there is a difference sa rotational speed when we compare it to a station na mas malayo or mas malapit sa ating hub. So, yun yung pinaka-idea niya. So, now for classifications according to position. This would just be a brief one. So we have tractor and pusher. One way to classify the propellers are according to their position sa aircraft. Seen in the photo, tractor is on the front of the engine and pull an aircraft through the air. Pusher on the aft end of an engine, and from the name itself, as it suggests, it pushes an aircraft through the air. Okay, so again, just for the sake of kapag magko-consult kayo ng ibang reference, hindi lahat ng references it is referred to as tractor. So yung iba doon, iba sa kanila, actually mostly, Jeppesen lang ata at saka pilot's handbook yung tractor, but mostly tinatawag din siyang puller. So kindly take note of that, pusher and puller. So when we talk about which one is more commonly used, we would say it is the tractor, and yung pusher, take note lang, is ginagamit siya sa seaplanes, mostly sa seaplanes. So when it comes to the quality of the air passing through the propeller, which is better, tractor or pusher? So it is tractor. It experiences lower stresses because it rotates in relatively undisturbed air. Kasi nga, yung air na, kasi unlike the pusher type, walang parts ng aircraft na madadaanan yung air as it goes sa ating propeller, thus affecting yung ating quality ng airflow. When it comes naman to propeller to ground clearance, which is better, also tractor. This is because pusher propellers they tend to be subjected to more damage than tractor propellers. Why? Kasi 'di ba in a pusher type, propeller comes after the wheels. So may tendency na magkaroon tayo ng FOD na involved. And when it comes naman to propeller to water clear, okay. So funny thing lang, familiar naman lahat sa sa term na FOD. Familiar ba lahat? Does it ring a bell, guys? Guys? Okay. Kasi, kino-confirm ko lang kasi may ibang section na parang hindi pa daw ata nila. Hindi nila alam. Sige nga, anong meaning ng FOD? Kasi meron siyang dalawang, pero pwede siyang gamitin interchangeably. So, anong meaning nyo ng FOD? Okay, Aligin.
Ano po, ma'am? Foreign object debris o kaya po foreign object damage.
Okay, very good. So, yeah, nag-comment din si Gadi. So, tama, ano? Foreign object debris and foreign object damage. You can use it interchangeably. So, bakit prone ang pusher type natin sa FOD? Kasi nga, yung position niya, behind siya ng wheels. So, pag nagko-contact sa wheels, lalo na when taxiing or taking off, landing, ganyan. Ano bang tendency if ever meron tayong mga ma-encounter na FOD dyan? So, kapag behind ng wheels mo yung iyong propeller, syempre dun siya pupunta. Unlike the puller or tractor type, nauuna siya before yung wheels. So, hindi siya magsasuffer kung ano, hindi siya sasabit sa propeller kung ano man yung mag-trap in sa ating wheels. Okay? Kinonfirm ko lang kasi meron akong turuan na section. My God, hindi sila, ano, masyadong familiar sa FOD. Pero, ayun, very good guys. Natutuwa ako sa section nyo. Bukod sa ang dami nyong pumapasok. Okay, yun lang. So, ano na tayo? Proceed na tayo. Runs, which is better? Of course, as I've told you before, ginagamit siya sa seaplane. So, ayun na. Propeller to water, pusher. As mentioned, diba, kanina, ginagamit nga siya sa seaplanes. Take note nyo. So, syempre, bakit? Kasi syempre, kailangan natin mag-maintain ng enough clearance from the water and the propeller itself. And since nasa dulo yung propeller natin for the pusher type, it is better. So, now we move on to the classifications according to establishing pitch. We now have two more major topics left. A few slides more. So, classifying propellers according to establishing pitch. The first one is, syempre, itong pangalawang classification na pretty much. Una is position, and this one is establishing pitch. So, the first one is fixed pitch na propeller. From the name itself, once the propeller has been built as one piece, the blade angle can no longer be changed. Okay, it is made as a whole. Pero, since I believe mas madami disadvantage nito, titignan natin yung major advantage niya. Which is dahil single piece lang siya. Siyempre, hindi magiging complex yung manufacturing nun. So, anong magiging effect niya? Magiging mas mura siya. And this way kasi mas mura nga siya. Fixed pitch propeller. So, next is ground adjustable propeller. Same lang sila ng idea ng fixed pitch in a way na hindi mababago yung blade angle natin while in flight. Only difference is, as the name implies, blade angle can be changed only on the ground by the use of clamping mechanisms. So, yun lang yung kinaiba niya sa fixed pitch. Hindi siya masyadong ginagamit sa modern aircrafts. Why? Kasi imagine, you have to be on the ground pa just to adjust your blade angle according on what your phase of the flight requires. So that totally does not make sense na you have to land pa every time you might need to change your blade angle. So next is the controllable pitch propeller. So as the name implies, we can change the blade angle mid-flight. Habang umaandar yung ating propeller, provided that limited lang yung pitch positions na magagawa. Take note na for this one, manual yung changing na gagawin ng piloto dito. And it operates either hydraulically or electrically. So the next classification is the constant speed propeller. So main difference nila ni controllable pitch propeller is for constant speed propeller, the pitch is automatically changed to maintain a constant RPM. So, 'di ba kanina manually? So, for this one, it is changed automatically. It speeds up when diving and speeds down when climbing kasi nga iba na yung load ng engine natin during those flight phases. When it comes to mechanism naman, this one has what we call the governor, which senses the engine speed and it changes the blade angle to keep the engine speed rather constant. The next one is reversible pitch propeller. So these are reversible pitch propellers. These are controllable. This falls under the controllable propellers whose pitch are changeable to a negative angle in flight. Main purpose niya is to produce reverse thrust, and having reverse thrust can make our landing roll shorter and makes the aircraft more maneuverable. And the last one, I think, last na ba to? Yeah, I think this is the last one na. For the feathering propeller, isa siyang kind ng constant speed propeller. We can change the blade angle up to 90 degrees to reduce propeller drag kapag may engine failure. So, medyo may nakaka-amaze actually na idea dito behind. Pero, madidiscuss natin yun sa helicopter proper pa. Making this one usually incorporated sa multi-engine na aircraft. So, yeah, medyo I'll try to provide more reference videos regarding the idea of feathering and ayun, may mga nakaka-amaze na parts lang dito. So, we move forward for our last topic, which is the propeller construction. Okay, sorry. So the first one is wood, of course. Main advantage ng wood is flexible siya, strong siya, and it can absorb vibrations well. But ang pinaka disadvantage niya is susceptible siya sa damage kasi nga hindi siya ganun ka-tough. Pero just think of it this way kasi tatlo tong materials na ay actually apat, sorry. Apat tong usual na materials na ginagamit dito. But the most widely used is aluminum alloy. Pero think of it this way, na each of this is an innovation that was created to compensate for the disadvantage for the earlier material introduced. So sa wood, since kailangan natin mas tough, in-introduce si steel. Pero since steel is heavy, nag-incorporate tayo ng hollow design lang na may vibration absorbent foam sa loob kapag ginagamit natin yung steel. So, ayun, pinaka-naging con ng ating steel is yung kanyang weight. So, aluminum alloy was introduced. This is the most commonly used type kasi nga strong siya and at the same time lightweight. So, the last naman na innovation is the composite. Composite propellers are gaining popularity din due to its strength and lightweight din siya. Kaya 'di ba, hindi lang limited sa propeller yung ginagamitan natin ng composite sa ating aircraft. So that pretty much is it. Okay. Now, yeah, yun lang pretty much yung laman ng ating first lesson. So far, meron ba tayong part na gustong i-clarify? Questions? Guys? Okay. Very good, ano? Tuntua ako sa section nyo. Ang dami niya na-give pumapasok. Okay. So, tuntua naman ako, no? Pero, ayun nga. Nakakuha naman ba lahat? Yeah. I believe naman ng orientation yan, sabi ko na sa inyo. Observe nyo lang kung ano yung kaya pang i-observe. Kasi bigyan ko lang kayo ng heads up for the laboratory kasi I just got pretty much the manual and the instructions for the laboratory activities and hindi siya mahirap. Sobrang dami lang. Madami-dami kayong gagawin. Kaya nga yung groupings nyo is by 5. So, secure na kayo siguro ng kahit siguro isang laptop tapos may backup kayo na isa pa na both may AutoCAD and SolidWorks. Come hand in hand kasi yan. And yung activity nyo kasi, I think, for the lab, yung una kasi about lang sa um, materials na ginagamit for propeller construction, yung wood, yung steel, aluminum alloy composite. So pretty much doon lang magre-revolve yung unang lab activity nyo. Ngayon, for the second one kasi, focus na tayo sa propeller construction. And we will begin it as soon as matapos na tayo dun sa second lesson natin. Kaya medyo pina-fast pace ko na kayo. Okay? Wala bang questions guys so far? Anything? Ang gagaling niya naman. Okay. So, ang next meeting natin is bukas. Bukas pala, no? 3:30 to 5. Am I right?
Yes po.
Okay. So, bukas, siguro kahit mga na tayo anyway, mag-post na lang ako sa Google Classroom if ever. Pero saglit lang yung magiging meeting natin bukas. Bigyan ko lang kayo ng overview. Fina-finalize ko pa din kasi yung sa lab instructions and pati sa lecture activities nyo. So, as soon as I'm done with it by today, discuss ko na rin siya sa inyo bukas para mahabol na natin yung second lesson agad. Makapag-proceed agad tayo para makapag-umpisa na kayo agad nung mga activities. Pero, ayun. Wait lang. Nakapaglagay na ba lahat ng groups? Wait lang. 1, 2, 3, 4, 5, 6. Okay, very good. Wait lang. I thought 31 kayo. 1, 2, 3. May isang group na 6. Tama ba?
Yes po. Tama po.
Opo.
Okay. Group of round 2C. Okay. Okay. So, ayun. Since naka-group naman na kayo, madali na lang to. Madali na lang siya, guys. Promise. Kasi, imagine nung college kami, both design and heli, individual namin to ginagawa. As in. Tapos, as in, pay laptop ka talaga pag kailangan mong mag-sign, mag-work, hindi ka sa SolidWorks. Kasi ibang subjects, direct. Ayun pa lang, be ready na kasi next week I will be giving you time to siguro yung time na to, bibigay ko na to sa yung range ng anong date ba to? October 24 to 28. 'Di ba nakalagay dun is supposedly async week natin to, activities and assessment. So bibigay ko na yung for the lecture and yung unang part ng lab. Bigay ko na siguro yung module for lesson 2 kaysa nung lesson 1 para mas-scan nyo na siya if you have time before natin siya discuss. Medyo matagal yung magiging discussion natin for that. Okay? So, guys, pag pinatapos na agad yung activity nyo, kung ako sa inyo, tapusin nyo na agad kung ano yung madadali na ibibigay ko next week. Kung masyadong ginawa kasi medyo ako trabaho siya. Pero for 5 people, even 6 pa nga din sa isang group, ano lang naman yun, feeling ko, kasi kami dahil, hindi lang yung binigyan. Ano siguro 1 week, isang, nun, kaya yun, lang, few pages lang. And every activity naman, magpo-post pa din ako. If hindi natin kayang mag-synchronous for that activity, magpo-post ako ng tutorial step by step nung pag what do you call this? Pag ng ating activity. And confirm ko lang, naalala pa ba, like kung mag-interpolate, kung anong ng projection sa graph ng values. Project tapos interpolate. Kasi accurate kapag nag-interpolate tayo. Familiar ba lahat? Sa aerodye, ganun. Familiar po lahat? Guys? Well, anyway, if hindi naman, ayun, yes po, medyo. Okay, kung hindi naman, as long as linear lang, sakto lang po ma'am, siguro mare-recall naman po. Okay, madali lang naman yun. If, okay, ano, ng foolproof na ano na tutorial for interpolation. Pero madali lang siya kasi para hindi tayo nag-a-assume. Masama 'yun. Masamang mag-assume. So, para masanay din tayo. Kasi sa design magagamit niyo din yung ano, skill na 'yun as you go on with your design. Pero kung nagawa niyo naman na before, recall niyo lang. Nasa din 'yan. Okay? I'll try to provide references para ma-refresh kayo tungkol dun. Okay? So, yun, what else? Okay, very good kasi nandito na lahat ng groups. Wala nang problema sa class list. Wala na din problema sa schedule. Okay, so chill lang sa session nyo. Thank you guys. Ano, yun. I want to thank you kasi so far kayo yung section na hindi sumasakit yung ulo ko. Every sem kasi, 'di ba, may gano'n kang section, may favorite kang section kasi hindi nila pinapasakit yung ulo mo. Pero ayun, so far kayo yun. So, ayoko ma-jinx. You're welcome po, ma'am. Best section na po ba? I can say for now. Pero ayun, natutuwa ako sa section niyo ngayon kasi ang dami niyong pumapasok pa din. Okay? I know patong-patong yung hindi gawain ngayon, eh, parang sunod-sunod yung sync ninyo sa schedule, gano'n. So, thank you kasi napasok pa rin kayo. And I'll do my best pa din siyempre para, favorite din kita. Okay. Okay, sige. So, ayun, ayoko lang ma-jinx kasi baka mamaya tuwang-tuwa ako sa inyo tapos dito pala ako unang bagsak, gano'n. Hindi naman ano. So, at saka ano, nakiki-participate din kayo, may mga sumasagot kapag ano, questions. Guys, kapag may question, participate lang kayo, kasi tini-take note ko yung mga nagpa-participate diyan and you never know kapag face to face na kayo, 'di ba? So, ano ba naman kayo, 'di ba? Finals pa. Okay, so see you guys sa finals and yeah, medyo madugo na 'yun. So, ngayon pa lang ipon-ipon na tayo ng pambawi ng grade diyan. So, okay. So, wala na bang questions, clarifications, reactions? Okay, may gusto
Naman po.
bang mag-share? Okay, kung wala naman na, I would be giving you guys the rest of the time to ano, prepare for your ano, software or kung wala pa, I have people kasi dito na nag-fill out nung form for SolidWorks license request and fina-follow up pa din kasi namin yung license for that kasi nga nag-expired na nga araw. Ayun. So, ayun, mag-organize na lang din muna kayo kung may next subject pa or yung mga hindi pa nagla-lunch. Kung may lakad pa, may date pa, sige, I will be giving you the time na. So, thank you guys. Again, I super appreciate your ano, maximum attendance. Sana hanggang dulo po ito. Okay? So, thank you and goodbye everyone.
Maraming salamat po. Good
Sige,
afternoon.
ma'am.
Thank you.
Sige po.